Hello guys, I'm sorry to be out again and that you are learning this material on the computer, but this is really just a new application for what we learned in the fall, which was all of this factoring skills, factoring polynomials, binomials, trinomials, difference of squares, difference of cubes, GCF, all that stuff. It's just going to be applied in another way, and that is simplifying rational expressions. So a rational expression is a fraction where our numerator and denominator are polynomials. So we have things being added and subtracted in the top and the bottom. So it's just like a really ugly looking fraction. So we call that a rational expression. So in our rational expression, obviously we still have rules about our domain. And our domain, remember, our denominator cannot be 0. And then it's undefined if our denominator does become 0. So starting off with just that review, looking at A, B, and C here, finding our domain, and we are going to be doing this in interval notation. So A is pretty easy. All I have in my denominator is n, so the only thing that would make that become 0 is if n itself were 0. So our interval notation for that domain would be negative infinity to 0, union 0 to positive infinity. And again, parentheses on all of that because we always use parentheses for infinity, and 0 is not included in our domain, so we're using parentheses. Now B, we need to figure out what would make n plus x equal to 0. Sorry, n plus 6 equal to 0. Well, if I subtract 6, that means n cannot be negative 6 because that will give me an undefined in my denominator. So again, interval notation here is going to be negative infinity to negative 6, union negative 6 to positive infinity, again, parentheses on everything. Now lastly, C. How am I going to find the domain on C? What values would make my denominator 0? So we have to find out what would make x squared plus 5x minus 6 be 0. And we know how to do this. We know how to solve a trinomial, and that is by factoring or quadratic formula, but this can be factored. Our leading coefficient is 1, so it's going to be pretty easy. I need factors of negative 6 that add to positive 5. That's going to be positive 6 and negative 1. So I have factored, and to find those values, we're going to say x plus 6 equals 0 and x minus 1 equals 0. So those two values are negative 6 and positive 1. I don't want either of those numbers plugged into my expression here because then I'm going to get 0 in my denominator. So how do we write this in interval notation? We're going to have 3 different intervals here, and the way that we do this is we go from least to greatest. So we're going to go from negative infinity, and then of my 2 boundaries here, negative 6 is smaller. So we're going to be able to go from negative infinity to negative 6. Then we're going to be able to go to all the values in between the two. Again, still smallest to greatest. So from negative 6 to 1. And then I'm running out of room here. And then I can go from 1 to positive infinity. So we have 3 different intervals here. And we're going from smallest to largest. Okay. So domain can't have 0 in our denominator. Then the skill we're going to be practicing and still using domain with is simplifying these rational expressions, and we do that when we have no common factors in our numerator and denominator. So we do this by, you guessed it, factoring. So to simplify a rational expression, we completely factor the numerator and denominator. We find and identify the domain before simplifying, and then you divide out any common factors to get your final simplified expression. So starting with A, let's factor our numerator and denominator. Our numerator here is a trinomial, so I'm going to want double parentheses. And as long as I can factor it that way, I won't need to use quadratic formula. So I'm looking for factors of negative 48 that add to 2. Well, that would be 8 and 2. So, sorry, not 8 and 2, 8 and 6. Positive 8, negative 6. So there's my factored numerator, and then in my denominator, I have a binomial, so I'm just looking for a GCF, and that's going to be 3. So that leaves us with x plus 8, 3 times x plus 8. Now, before we start simplifying and canceling like terms, what we need to do now is identify our domain. so our domain. What would make our denominator equal to 0? So what's going to be focused on here is what's inside my parentheses, this x plus 8. What would make x plus 8 equal to 0? And that would be if x was negative 8. So there's my restriction in my domain, and if we're going to write that in interval notation, that would be negative infinity to negative 8, union negative 8 to positive infinity. Okay. So there's my domain. I've factored my numerator and my denominator, and now I can divide out common factors. So the thing about these common factors is, remember, they have to be being multiplied together, okay? Starting out, let me find an example here, like on C. You have an x squared and an x squared, but you can't just cancel these if they're not being multiplied. Something needs to be protected by parentheses, and your parentheses match exactly in order for them to simplify. So like x plus 8 and x plus 8, those are protected by parentheses. That means I have multiplication happening here. So I can cancel those like terms, and I'm left with x minus 6 over 3. That is our final simplified rational expression. All right, let's practice some more on B. Let's factor our numerator and denominator. In our numerator, I have a binomial, which means I'm looking for a GCF, and that is x. So if I take out x, that leaves us with x squared minus 9. And in my denominator, I have a trinomial, so we'll factor with our double parentheses. Leading coefficient is 1, so I'm looking for factors of positive 21 that add to negative 10, and that's going to be negative 7 and negative 3. All right, so before we start simplifying any further, let's identify our domain. I'm going to do that up here. So what would make our denominator 0? Well, that would be if x was 7 or if x was 3. But of course, we're going to want this in interval notation, and we're going to be, again, practicing. We're going to have 3 intervals here going from smallest to largest. So we're going to go negative infinity to, out of 3 and 7, 3 is the smaller. And then I'm going to have my interval from 3 to 7. And then from 7 to positive infinity, again, all parentheses. Okay, so there's my domain. Now, looking here, off the bat, I don't see common factors that I can cancel. However, I hope you already identified this is a difference of squares. So that can be rewritten as x plus 3 times x minus 3 in my numerator. And now I have x minus 3, again, protected by parentheses. They match exactly, meaning it's being multiplied. So that can cancel. And our final simplified expression is x times x plus 3 over x minus 7. Now, you might be tempted to distribute that x, and that would be fine, but that's just extra work because we're not going to be able to simplify anything further than that. So it is acceptable to leave your expression in this form. All right, let's keep going. C, all right, we need to factor and simplify. So I have a trinomial on the top, but my leading coefficient is bigger than 1. So we are going to factor by grouping, or if you have the Mustang method, whatever it is you like to do, that is totally fine. So I'm going to go ahead, and 2 times 4 gives me 8. I'm looking for factors of positive 8 that add to negative 9. Well, that is negative 8 and negative 1. Okay. And then in the bottom, what I'm going to do is I like to rewrite this with our greatest exponents in the front. So I'm going to rewrite that as negative x squared plus x plus 12. Okay. So now into our top again. GCF, factor by grouping. Here are my first two. On the first two, I can take out a 2x, and that leaves us with x minus 4. And then I'm going to factor out that negative 1 here, and that leaves me with x minus 4. Then in my denominator, what I'm going to do is take out that negative in the front and change the sign of everything inside of my parentheses. Okay, so common factor in my numerator is that x minus 4, that leaves us with 2x minus 1. And then in my denominator, I can factor that trinomial, keeping that negative on the outside. That's going to give me x minus 4 times x plus 3. So quickly, before we simplify further, let's identify our domain. X cannot be positive 4 and x cannot be negative 3, otherwise we'll get a 0. So in interval notation, again, smallest to largest, negative infinity to negative 3. Then I can go from negative 3 to 4. And then I can go from 4 to positive infinity. All right. Now let's cancel our like terms. I have x minus 4 and x minus 4. So 2x minus 1 over negative x plus 3. And again, you can distribute that negative if you'd like, but it's also acceptable to leave it this way. All right, last one on this page. Again, we need to start factoring and simplifying. Looking across the top, I have a GCF I can take out, and that is 2. So that leaves us with x squared plus xy minus 2y squared. I'm running out of room, so that parentheses is kind of squished. And then in my denominator, I can take out a GCF of 5x, and that'll leave us with x squared minus 5, or sorry, not 5, take out the 5, x squared minus y squared. Okay, so now factoring further, I'm going to draw a little division line here so you know I'm working on example D. In the top, x squared plus xy minus 2y squared. This one looks a little tricky off the bat. It is still going to be our double parentheses. X squared, I know that's going to be x times x. Now, negative 2y squared. I know I'm going to have a y and a y, but one of those is going to need to have a coefficient in order for, if I were to FOIL, to get a negative 2. So, with negative 2 and then the coefficient in the middle being positive 1, I know that's going to be a positive 2y and a minus 1y. And again, if you were ever confused on that, you could FOIL to check that you factored correctly. Then in the bottom, I have the 5x. And then this is actually a difference of squares. So x plus y times x minus y. And now let's go ahead and identify our domain. What would make our denominator 0? Well, I have this 5x being multiplied here, so that tells me that x cannot be 0. Then I have two other values that would give me 0. So whatever y is. So x could not be y, and x could not be negative y. Either of those values will give me a 0 in the denominator. And now I don't know what exactly y is. So we're going to go with negative infinity to negative y to 0, and 0 to y. I'm just going to assume that y is some positive number. And there's our domain. Now lastly, simplifying, the thing they have in common is this x minus y. So then I can bring everything else down. And there is our final simplified expression. This next page, I don't have my TI-84 at home with me, so I'm using an app on my phone, so it's going to look a little bit different, but you should know how to do this on your calculator. And if you have questions, obviously I can walk you through that. But we are going to fill in these values using our table. So the first thing you're going to do is type this into y1, this into y2, and this into y3 on your calculator. Now again, I'm using a different app, so it's going to look a little bit different. But here I have my y1, y2, and y3. What's really important here is that you're protecting everything with parentheses. If you have something being added or subtracted, that entire part needs to be surrounded by parentheses so the calculator knows exactly what you're meaning. So you're typing in y1, y2, y3. Then in your table set, you want it to start at -4, increase by intervals of 1, and then all of these settings should match. Then you're going to go to your table, and I'll have to scroll down a little bit just to see because I'm using a different app. And we are going to copy, so for -4, here are the values for 1, 2, and 3. And you're going to copy all of those from -4 to +4, and now I'm going to pause to fill that in, and you can catch up. Here are all those values you should be getting from your table. Anywhere that you saw the error, that's an undefined value for our expression, and that meant that we ended up with 0 in our denominator. That's one of the boundaries for our domain. Okay, so in y1, your domain could not include -4. In y2, your domain could not include 2. And in y3, our domain could not include 1 or -3. So that's what this is showing you, is how to identify on a table where your boundaries are. Now those last two, I'm not going to work, but you can check. You would factor